All right, video two here. So now what we're going to do is we're going to put these reference angles to, uh, we're going to figure out how to find them, actually, and we'll do a couple examples with this. So what we're always going to do is, I think it's easier for most of us to graph angles in degrees, right? I think we understand the degree thing, and we're going to probably understand the degree thing a lot better than radians, just because it's what we're familiar with. It's what most of us have used for, a decade and a half, maybe more. And so that's what we're going to use. So for this first one, we have 210 degrees. And so if you remember kind of how to do that, well, we think of things in benchmarks. Well, if we start here, right, you always start by drawing your initial side, right? Your initial side, your vertex is always the origin. You put your ray going here. So this is your initial side. This is positive, so we're going to be going this way. And then you just kind of figure out, all right, how many like quadrants do we got to go through? So this is 90, another 90 makes it 180. And then if I go another 90, that puts me too far at 270. So you just say to yourself, or just on paper, so let's subtract 180 to see what's left. And so what's left is 30 degrees. So if each of these is 90, 30 degrees is about a third of that. It's not about a third of that. It's exactly a third. And so it would be about there. Okay, and then you just take this and you go boom, right? And this is your major angle, right? This is your theta. So this would be our 210 degrees. Now we're not done. They want us to find the reference angle. So the reference angle is, you see where this is, right? So we're gonna look at this right here. We're gonna say, okay, this is what we're referencing it to, and then you reference it to the closest x-axis it's near, and so it's near the negative x-axis. So we're gonna compare it to this, right here. And so what we want to find is we want to find that. Right? We want to find, let me make this a little more. This is what we want our reference angle. We're going to call that theta prime. All right? And so the way we find that is you look at your original angle here and you say, okay, this was 210 degrees. I know that this part that we're not using was 180. So we're just going to take that away from it. So we're going to go 210 minus 180 gives us 30 degrees. Now you might be thinking, well, goof, we already found that, right, when we were graphing it. And yeah, you know what, you did. And that's kind of the point, is that if you're graphing these things, you can find the reference angles pretty quickly most of the time, if you're graphing them in relation to the x-axis. If you're graphing them in relation to y, then that's a little different, right? But it's always in relation to x-axis. So it's what's this angle right here. Don't worry about positive or negative. And so your answer to this is 30 degrees is your reference angle. Okay. Now let's do this one. And so we're going to do this in radians and degrees, so we kind of understand it. All right. So let's get back here. All right. So let's graph it first. Let's sketch it. So negative means we're going to be going this direction. We're starting here, all right, and then it's negative 5 pi over 4. So if you remember when we're talking about radians, right, we have 0, and then we have pi over 2 is your 90-degree mark, and then pi, right, and these would be negative going this direction because this is the direction we're going, and then this would be negative 3 pi over 2. So negative 5/4 pi, if we put it in terms of like halves, right? So it would be like 2.5, or yeah, it would, or not 2.5. It would be oh, my brain's not working. Yeah, right. It's going to be kind of in here. It is going to be 2.5 halves, negative 2.5 halves. So it's going to be right in between here, between this one. And if you're not sure to get it that way, just think, okay, well, if I take negative 5/4 pi, and let's just ditch the negative for a second. If I take 5/4 pi and I say, okay, I know it's bigger than 180 degrees because it's larger than 1 pi. So let's just subtract pi from this, right? And if you subtract pi, if you take pi, or 1 pi away from 5/4 pi, you're left with 1/4 pi, right? That's what you're left, or pi over 4. And pi over 4 is half of pi over 2, which is the distance from one axis to the next. All right, it's always pi over 2 radians each way. So my pi over 4 is going to put me right here, right? This would be my terminal side. Here's my initial side, my terminal side. And so my theta, my regular angle, is going to be here. It's going this direction because it is negative 5 pi over 4 radians, right? That's what we got. Negative 5 pi over 4 radians. So now, to find my reference angle, I am going to look at this angle in relation to the x-axis. So I'm going to sketch it in red, and then it's going to be in relation to this here because that's the closest x-axis. So we want this angle right here. So that's my theta prime. And so you kind of found that already. Again, you found it because it's 1/4 pi or pi over 4. So the reference angle is pi over 4. Now you're going to keep it positive because reference angles are always positive, right? It doesn't matter. The rotation of the reference angle doesn't matter as long as you know where it is, right? And I know that this is in quadrant 2, and we're going to use that in the next set of skills we use. But this is how you find it, right? And so it's pi over 4, and then to figure out what that is in terms of regular degrees, you would say, okay, you have pi over 4 radians. We're going to multiply this by our converter, which is pi radians, and then 180 degrees on top. Remember, you always put the unit you want to get rid of on the bottom, so they cancel, your pi's go away. You have 180 divided by 4, which gives you 45 degrees. And you kind of should have been able to figure that out. Or you could have figured that out from saying, well, I know this is 90, and it's half of that, so half of 90 is 45. So always feel free to use common sense on these as well. So these are your answers. Pi over 4 radians is probably the answer they're looking for, but I think it's helpful for us to know that it's also equivalent to 45 degrees. All right, so in the next video, we're going to talk about now applying sine functions to these. So we will see you there.